All right, so we finished this section, this problem. To the next one. Notice on this problem that we just did, it's between two amounts, and so we put the this is the low number, that's the high number, all right, and then we put the standard error, the standard deviation. All right, so the mean room and board expense per year for your college, $75.40. You select 9 of them for your colleges. What's the probability that the mean is less than 7,800? Assume the board expenses are normally distributed and the standard deviation is 1245. All right, if this did not say, okay, it's 9, so it's less than 30, and if it didn't say it was normally distributed, we could do nothing with the data. All right, so it's really important that we see that if it's less than 30. This guy up here was more than 30, so it didn't matter if it was normal or not. All right, so let's focus on how to type in the calculator. It's less than, so the shading is on the left, like when we draw a normal distribution. Okay, and we're going to, which means that this 7,800 is going to be the biggest number. So we're going to do our normal, and then we put the smallest number. So we'll use that standard 10,000, and then the biggest number for our interval. And then we put our mean. And then we're going to put the standard deviation, but we can't put the standard deviation here. That's what we normally do, right? Because it says, what is the probability that the mean? It doesn't say an individual. And so since it doesn't say an individual, we need the standard error. And the standard error is the standard deviation divided by squared n. Right here. Okay? And so we're going to fill it in and do our formula, and we get 4. Let me double check that. Yeah, 415. All right, so I'm going to type 415 right here. All right, so second bars go to normal CDF, negative 10,000. And then we have that 7,800, our mean, 7,540, and then the standard error, so that 415. And this is the number that we get. And so this means that 73%, the probability that the mean is less than 7,800 is 73%. Excuse me. Let's look at this one. Okay, so we've been working on how to do how to use that new formula, all right? And so now let's combine the new formula and the old formula that we know and figure out like when we use one and when we don't, okay? So the average time spent, this should be by construction workers on weekends is 7.93 over 2 days. Assume the distribution is normal, has a standard deviation of 0.8. All right, so let's look at the difference. Find the probability that an individual who works at the trade fewer than 8 hours, or B, find a sample of 40 construction workers are selected, find the probability that the mean of the sample is less than 8 hours. All right, both of them, let's look at what they have in common. Fewer than 8 hours, that's also fewer than 8 hours, okay? We both want the probability, which is the exact same as like the area of the curve, so that's what we're doing. Here's the difference. This one says individual, and this one we want the mean. Okay. Another difference is that on this guy, it tells us n. It tells us n, and we need that because that new formula has standard deviation divided by n. All right, so over here. Okay. Because this is an individual, we're going to use that formula. And because this wants the mean of the sample, we're going to use our new formula. Remember, the new formula is x bar minus mu, standard deviation over square root n. Okay, and the old formula would be x over standard deviation. All right, so let's do this problem. Okay, so we want an individual over standard deviation. So those are the things we need. All right, fewer than 8 hours. So 8 hours, so that would be left. Now, okay, and we're going to do standard deviation is 0.8. The average is 7.93, and then our thing is 8. Okay, so I'm going to do 8 minus 3 over 0.8. Oh, I'm trying to get my calculator. Wait, 0.08. Oh man, guys, the struggle's real today, apparently. 0.0875. So that means it's 8.75%. The probability that one individual is going to work fewer than 8 hours. All right, now let's compare that to this guy, where that's in. And then we want the mean of the sample, so we're going to do x mu, standard deviation squared n. All right, so we have x 7.93 mu, or I'm sorry, this is mu. 8. I totally did it backwards on the previous problem. I'm going to go back in a minute. Standard deviation is 0.8. So we're going to do 7.93 minus 8 over 0.8 over square root 40. 7.93 minus 8 negative 0.07. 0.8 divided by square root 40, we'll say is, I don't know, 1.3 or 0.13, so 0.07, 0.3. All right, we get negative 0.54. I confused it right here, guys. Got my brain. My brain is on vacation, yo. All right. X is 8. Mu is 7.93. Okay, 8 is like the thing we're looking for. I am so silly. So positive. All right, so we get positive 0.54. So 54%. The sample of 40 construction workers, the probability that the mean of the sample is less than 8 hours is 54%. Let's try that again. All right, an education finance corporation claims the average credit card debts carried by undergrads is normally distributed, mean of this guy, standard deviation of that guy. Probability that a randomly selected undergrad has a credit card less than 2,700 versus you randomly select 25 undergrads and you want to know the probability of their mean credit is less than $2,500. All All right, so we're going to use the old formula here, and we're going to use the new formula there. All right. Do that. All right, number 1. And so I did this so you wouldn't have to see my horrendous. Oh, you know what we did on? Oh, Kelly. Okay, you didn't have to see my horrendous handwriting. All right, so we want undergrad less than $2,700, minus 31, standard deviation 1120. All right, so hang on 1 second. Standard deviation. Okay, so this is if you wanted to do it by hand. But remember, you have the skills now to do it in the calculator, which I was double checking because I don't want to tell you wrong. All right, so it's less than 2700, right? So here it is, and I don't know, 2700, and then shaded, so that's to the left, which means the smallest value will make up. The highest value will be that 2700. Then the mean and the standard deviation. So the mean, and we're doing the standard deviation because it's a individual. It's one thing. And so the mean was 3173. Standard deviation was 1120. And we're going to stick that in our calculator. Okay. Here we are. Stick that in our calculator, and we still get 0.3364. All right, let's look. And we get same thing, 0.3372. This is dealing with a whole bunch of rounding, so I would be fine, you know, either one of those numbers, 33.6, 33.7 is fine. All right, and so since we now remember this formula, let's go back and do this guy on the calculator. So, I don't, normal C, D, F. Okay, fewer than 8 hours, so comma 8, comma, you want the mean, 7.93, and then you want the standard deviation, 0.8. All right, let's type that in our calculator. I hope you're typing with me. 8, 7.93, 0.8. And we should get the exact, the exact same number. And here's why we don't, is because this is here, and then I need to look that up on the Z chart and see what that is. So I realized that last problem when we were doing it. All right, so then we look it up, or we can do the formula. Okay, nevertheless, I get 0.535, so it's 53%. Okay, which makes a lot more sense because this guy over here was right around the same thing, and they should be fairly normal. All right, for here, what we need to do is normal CDF. It's still less than 8 hours, so the smallest one, and then 8, and then the mean, 7.93. And our standard deviation, we need to write the standard error. That's this piece. Okay? So if you want, you can just type in the comma, parentheses, 0.8 divided by square root 40. Or you can figure out exactly what that number is and then type it in. Okay, so I'm going to type it in. 8,793 parentheses 0.8 divided by square root 40. 0.8 divided by square root 40. Hang on. 0.13. All right, and then I'm about to show you something. 0.8